Okay, we're in section 36 of the notes, and we're going to go through the homework. Again, the point of me going through the homework is to show you what I would do if I were doing homework. You got to do homework, though. It isn't me doing homework. Why do we do this for you? So for the students that need to, that extra crutch of watching someone do homework for them, the bottom line is, even if you're watching me, you still have to do it on your own, all right? That could be rote learning, which is not good. It's not going to be productive for you. But for the most part, a lot of your learning will be rote learning. What does that mean? You're really just repeating what someone else is doing anyway, and little to understanding what they're doing. This is not going to go forward on you, though. You need to find an area where it's not rote for you, where you're actually engaged in what you're doing and you're capable of doing it independent and synthesizing into something bigger. That's the point of an education. So I'm going to switch screens now. I'm going to switch screens to the whiteboard. Give me 1 second to do so. And I work one problem at a time. And certainly, number one, fairly simple. The work is written down for me. Clearly, I could read the work. That's not my intent, though. I did typeset this for you, but that's not my intent to read my typeset work. My intent is, if I were doing this as a student in the classroom, I would be following the instructions as if I would, the indefinite integral, use the substitution that they're writing for you. So let me write this down. What I would be writing down on my paper and pencil, I would say, oh, they said use u equals x squared plus 6. And then du would be 2x dx. And I'm going to say 1/2 of a du would be equal to x dx. All right. And they want me to use this on this integration over here. And we'll look at the key later. I'll push this over. And what I'm going to do is just underline what I'm seeing. I'm seeing this. Right. I definitely see that. And I see this. I'm seeing it. All right. I'm definitely seeing it. So what I'm going to do, I'm going to try to make a substitution. It's called u substitution. So what's x dx equal to? 1/2 of a du. And what's x squared plus 6 equal to? It's equal to u. So it's going to be u to the 5th power. Well, what I need to do is I need to integrate this, but I need to remind you that this is not the integration we want to do. We want to do the integration with x in it. So we go here, write this down, 1/2 u. I increase the exponent by 1. Divide by the next exponent, add c to it. What do you have here? Well, this would be 12. And what's u? And u is going to be x squared plus 6. This is my answer. Well, what I do over here, well, I look at it, see if I got the right answer. It's all I'm doing. Wow, that's a miracle. Let me do the next one. And next one, I'm kind of looking at it, and certainly I'll do it step by step. But as I'm looking at this, say evaluate that indefinite integral, and they give me the u substitution. What's that going to be? U equals 24 t squared. Whoops, I forgot to put the 4 there. Plus 5. I'll put the du down. That's going to be 48 t dt. This is 1/48 of a du is equal to t dt. So I'm kind of looking at it, and what I'm looking at is I'm looking at the integration t. That's the root of 24 t squared plus 5 dt. Well, let's kind of underline things. I think I'm seeing this. And what's that going to be? Well, that would be written down as u. It's a u problem now. And I don't want to be in a u problem. I go back to t's. So it's u to the 1/2. All right. What's the next thing I'm seeing? T dt. And what's that one? That's 1/48, right? I'll have to put the caps on the outside. Du. Can I integrate that guy? I sure can. And what do you get? 1/48. That would be u to the 3/2, right? Divide by 3/2 or multiply by 2/3. Plus c. Remember, we need to go back to the t in the problem. What do you get over here? And I got to be careful about this. Well, it's going to be 2 at 48, 24. 24 times 3, 72, right? And then you get u to 3/2, which is going to be u root u plus c. And what's u? I got to remind myself. Oh, it's 24 t squared plus 5. Who knows? Maybe I got the wrong answer. Let's go to the next page. I'm going to copy their answer. I don't know, maybe it's wrong. I make mistakes all the time. And this is what we're trying to encourage you. And really, we're trying to teach you, that basic skill of doing homework. And this is something that I really say that, when you were a child in school, hopefully you went to a school where they actually asked you to do homework. All right. Now, what does that mean? You go home and you work on stuff. And that's what's called independent learning. And that's the goal in life, is to become independent learners. And we would like everyone to become an independent learner. All right. So let me go back and I'll paste it in over here. Give me 1 second to do so. Did I get the right answer? It's a miracle. We're doing good. I feel comfortable that I can actually move forward. Let's go to the next page. And I like this. I like the fact that they're giving me the substitution. It makes my life a lot easier. All right. I like to be given things. All right. So what are you giving over here? I'll write this down for you. You're given u equals x plus 10. And that means du is equal to dx. So I'm going to write the integration down, and we'll do it one step at a time. I'm going to pull a 22 on the outside because I really don't like that guy. So x squared. And when you get over here, I'll write this down as x plus 10 to the 1/2 power and a dx. All right, let me put it over here. It's going to be a little tougher this one. It looks like it might not work. Here's the deal, though. There's no way they're going to give you something that's not going to work. It's just not going to happen. It'd be crazy to do that. And what do you get over here? I'll underline this for you. I know what x plus 10 is. It's u. So it's u to the 1/2 power. And then I got dx. And what's dx equal to? It's just equal to du. I got this x squared business over here. I'm wondering what to do with it. So what I got to do is I got to write this guy over here. I got to solve for x. So it's going to be u minus 10 is equal to x. Oh, I got to square that, right? So I'm write that down. What do you get? U minus 10 squared. Things are not looking good now. So I got to work on it. And I'll put this over here. And by the way, I'm being facetious saying they're not looking good. We don't give you things that don't look good. We give you things that work out really nicely. Well, it's going to be u squared minus 20u plus 100 times u to the 1/2, right? du. This is 22. Thank God for answer keys, by the way. We'll be able to look at it. Oops, sorry, I lost track of that. That's going to be u. We'll have to increase it by, I'm sorry, multiplying. I didn't increase it. U squared, that's 4/2, 5/2 now. I'm simplifying the integrand. 20u 3/2 plus 100 u to the 1/2. And that's du. I think I did okay. Let me keep going. I know it's work. What's the worst part of work? If you don't enjoy it, that becomes a nightmare. We're trying to encourage you to find work that you enjoy, though. Hopefully you're in a STEM career that you enjoy doing STEM-related material. So I have to increase it by 1. That's going to be 7/2, right? Divide by 7/2, like multiplying by 2 7s. Minus, I have to increase 3/2 by 1. That's 5/2. And multiply by 2/5, right? We'll simplify that later, don't worry. Then we get over here, I got to increase 1/2 by 1, that's 3/2. And then I have to multiply by the reciprocal of that, which is 2/3 plus c. Yeah, it's work. Oh boy, I got to do some more work here, don't I? So let's write this down. And I'm going to try to simplify a little tiny bit. 5 goes into 5 once, it goes into 4 times. All right. I'm looking at it. I really want to simplify this. This doesn't look good. So 22 common denominator would be 21, right? All right, here comes the tough part. I would get 6 because 3 times 7 is 21, right? U to the 7/2 minus, well, that's going to be 8, right? Because 2 times 4 is 8. And then what do I get? I'd have to multiply by 21, right? 8 times 21. Well, it's going to be 168, right? Boy, that's a nasty number, huh? Plus, oh boy, this is going to be a tough one too. 200 times 7, 1400. Now it'd be u to the 3s. It's not over yet. I'm going to factor that guy because it looks nightmarish. 21, 22. Well, I'm going to say a 2 definitely factors out. And a u to the 3 halves factors out. And what do you get? You get 3u. 4 halves would be 2. I factor a 2 out. That would give you, let's see, 84, right? See if I did that right. I said I factored 2 out, right? 2 times 80, 160. Let's see, you get u to the 2 halves, which would be u. Then you get 700. Factor 2 out, right? Plus c. So it's way too much work. It's a lot of work. I realize that. Mistakes are going to happen. We're going to make mistakes a lot. So I can't remember. It's x plus 10. $44, 21, 3, x plus 10 squared minus, I'm sorry, make sure I did the right u. Yeah, u is x plus 10. Minus 84, x plus 10 plus 700 plus some constant of integration. All right, it's tough. All right, now so is it over yet? I don't know. I gotta look at my K. And let me just see if I'm looking at it. I see the 44. I see the 21. I see the x plus 10 to the 3 halves. I see the C, but I'm looking at this and I'm looking at what they wrote down and I wonder if I got it right. And I don't know. So I'm going to write down what I wrote down instead. So I wrote down this 3x plus 10 squared minus 84 x plus 10 plus 700. And by the way, I'm just checking to see if I got a right answer. I don't want to write that answer down and say it's right when it's not right. That would be crazy. So what do you have here? 3x squared plus 20x. We're just checking. Plus 100 minus 84x minus 840 plus 700. Boy, I got a lot of work to do, don't I? 3x squared. I'm just checking. I'm kind of sloppy when I'm checking too. Plus 300 minus 84x minus 840 plus 700. So that would be 3x squared minus 24x. What do you get over there? That's 720. I'm sorry, that's 700. I was so sloppy, I can't read my work. 1,160. Let's see if that's what they said. 3x squared minus 24x. Wow, we got it. So here's the deal. I did some work. I didn't do it all. But the bottom line is when you're doing homework, check it. Make sure you get the right answer. And this is, of course, the right answer. We did check it. Not that they were identical answers in appearance, but they were identical in content. So that was number 3. We're going to go to number 4 now. And whoops, I got to get to number 4. I'll just copy paste this one, okay? The next page. And I'm going to town. I'm going to work. All right. Use substitution. I got it. What am I going to do? I'll do the du on it. Oops. Let's go back to black ink. So what's du? Du is equal to cosine theta d theta. Some people say, do I need to write that down? You need to write that down. You need to get graded. So what do you get over here? Let's write this down. This can be a star because I'm going to change back to thetas. This is going to be, let's see, that would be u to the 9th. And then cosine d theta is going to be du. Wow, that's an easy one. What do you get? u to the 10 over 10 plus c. What's u? It's sine theta. We write the 10 there over 10 plus c. Let's look at the key. And I do mean that. Look at the key. And we're looking at it. And I got it. It's right over here. I feel good about this. All right, let's go to the next one. Again, this is awful kind that they're giving me the actual substitutions. And maybe I can do these in my head, but here's the deal. You're not to do things in your head. You're to do things by writing them down. So what's du? That's secant squared, isn't it? Let me go over here, underline this for you. I'm seeing that. And I'm seeing this. So let's write this down. Put it over here. What's that going to be? 6. Put a star over here, indicate I need to go backwards. And let's see, I got the 6 out. Secant squared x dx is going to be du. I'll put this down. And the tangent x is going to be just a u, right? So what does this give me? This gives me 6u squared over 2 plus c. Again, we need to go back to the land of the x's in the problem over here. So it's going to be 3 tangent squared x plus c. Do mistakes happen? All the time. Look at this, I'm not agreeing, you know they made a mistake. All right, a little more difficult, and number 6, but again, they're still giving me the substitution. All right, I'm going to copy it, bring it to the next page. Paste it over here. And again, the reason I'm doing this, I want to look at the key later. So they tell me what to do. I like that. I like to be told what to do. Du, let's go back to black. Du, therefore our tangent is going to be 1 over 1 plus x squared dx. Okay, I'm going to circle this. I'm seeing it. It's right here. And that's the du. Let's write this down. Whoops, go back to black. That's du. And arctan of x was u, so it's going to be u to the 6th power. What do you get over here? U to the 7 over 7 plus c. Again, you got to go back to the land of u's. And what was u? It was arctan. So it's arc tangent of x raised to the 7th power over 7 plus c. Circle on this, indicate I'm committing to that. I want to look at this. I want to look at their answer, and we're getting a miracle, the same thing. All right, let's go to the next one. And it's really not that bad. I'll push it on the side over here. And again, as you're doing homework, it's for your benefit to do homework. I want to tell you, when I used to do homework, I would basically do it on a piece of paper that was scrap and just basically throw the homework questions out later. No need to look at it again. I knew I mastered the material. I want to say historically, students, when they were giving homework, they didn't have an answer key though. Now, what I mean by that, an answer key with work in it, nor did they have videos for them to look at later. What they typically had was a final answer, and that's all they had for some of the homework, and that was just for the odd problems. So all they had to look at was the final answer. They didn't have any work down, no work whatsoever, all right? Later on, they start to publish answer keys for teachers to have, but not for students to have. Things have gone completely in the opposite direction. We're giving students all the work, all the answers, videos, plenty of support. Is it making for a better educated population? Probably not. I think, and I hate to go, retro on you, but in the old days when you were giving very little support, you were kind of alone. You really had to come up with a lot of resources to get these answers over here. But anyway, what do I know about this problem over here? No hint. All right, but I know I got work over there. So I'll write this down, but there's no hint now. This is like, so like your parents gave you an allowance and all of a sudden they say, no allowance. You're on your own. So I'm going to look at it. I'm looking for some function whose derivative is contained in a problem, and I see it right away. So I'm going to say u equals x to the 7th, and du would equal 7x 6 dx. 1/7 of a du is equal to x6 dx. Well, I am now ready to write this down in the land of u's. So let's see, x6 dx is going to be 1/7 of a du. And the cosine x7 is going to be cosine of u. Now, by the way, if this is not an easy integral, we're doing something wrong. But this is a lot easier. What's going to be 1/7 of the sine of u plus c? Do I know what u is? I do. It's 1/7 sine, and u is x7 plus c. Look at the key. And what are we seeing? We're seeing our answer. All right. This one looks crazy. All right, let's copy paste. No hints are given. Next page. And again, no hints are given. So I got to work on it. I'm looking for something. I can make a stab at it. And again, you'll get better over time by trying. And I want to indicate that you will get really good at what you try, including if you're trying bad things, right? I see this happens to a lot of people. What they do is they try bad things and they get really good at doing those bad things. I don't think you want to do that. You want to do good things. I'm saying school, good thing to do is homework. So let's put this down. I'm going to write this down for you. So I'm going to say, I think u sine 9x might be a good substitution. And the reason I say that is I see its derivative in the problem. And what's derivative of sine? Cosine 9x times 9 dx. I'm seeing the problem. And of course, when I see it, I'm going to put it over here now. Look at the key later. So I'm seeing it. I'm seeing this. I'm seeing cosine 9x dx. What's going to be equal? 1/9 of a du. Now, but always always question, why are these problems working? We are writing problems that work. That's the bottom line. Or I should say we're selecting problems. There's nothing creative about this. There's a selection of problems. What do you get now? Cosine of u. Do I know what's antiderivative? I sure do. I'll write this down. We'll check with the key later. 1/9 sine of u plus c. What's u? Well, it's sine of 9x. It's going to be sine of the sine 9x plus c. Let's look at the key, see if we got that. And again, I'm looking at the key, sine 9x over 9. Wow, miracle. We got that one right too. All right, let's look at this one over here. And I'll be honest with you, this can get really, really tough for some students that don't believe we're giving them problems that work. We are giving you problems that work. Let's take a look at it. Put this over here. All right, and I'm going to write it down for you, and I'll try to get rid of the answer key in a second. So I'm going to write this over 1, 2x minus 5 to the 5th power dx. I push this aside, and let's see if I can do it. And I'm going to say, I don't know what to do, but I have to make a u substitution because I don't recognize the integral. So I'm going to say u equals 2x minus 5. Now, someone says, why are you doing that? Because its derivatives contain the problem. And what is the derivative going to be? 2 dx. I'm clearly seeing that. All right, so let's write this over here. Let's start over here. 1, this should be u to the 5th on bottom. That was easy. And what's dx equal to? 1/2 of a du. All right, this worked out pretty nicely. So 1/2 u to the minus 5 du. I can integrate that guy. So it's 1/2. I increase the exponent by 1, minus 4, divide by minus 4 plus c. Let's keep going. And again, we'll talk about this in one set at a time. So it's minus 1/8. And then I get u to the 4th on bottom, right? Plus c. What's u? No need to memorize. Whoops, sorry about that. No need to memorize. That's why things are written down. And I can't say it enough times to you. Write things down. Mistakes still happen, by the way. And I want to look at my answer. And I want to see if they got that. And if they didn't get that, you know what? I'm going to do the problem again. So whether you over here, minus 1/8, 2x minus 5 to the 4th power. Looks good. All right, let me do number 10. And again, I'm going to do a copy paste here. Again, they're not giving me any hints at all. Next page. And I'm going to look at it. Okay. And I'm wondering, no hints, right? So let's take a look. By the way, you're going to make decisions that are bad decisions, but at least know you made a bad decision. Like if you start with something and life is getting worse for you, you need to back up. I'm going to try something. And I make tons of bad decisions. What's du? 20x plus 2 dx. Du 2 10x plus 1 dx. Boy, that worked nicely. What I'm looking at, I'm looking at this. What's that equal to? 1/2 of a du. Then what do you get in the bottom? You're going to get 1 over now. 1 over what? That would be u cubed, right? Certainly easier to deal with. What do you get? 1/2 u to the minus 3 du. Keep doing this. This is 1/2. Increase the exponent by 1, minus 2, divide by minus 2, plus c. Let's keep going. This is minus 1/4, a u squared in bottom plus c. This is going to be minus 1, 4. Again, what's u? 10x squared plus 2x squared plus c. Again, I am going to recommend that you look at the answer key that we provide to you and see how you did. And what am I looking at? I'm looking at this. Did you get it right? Minus 1, 4. Wow, miracle. Again, we got it right. By the way, it's really not a miracle. Let's do number 11. I'll write this down. So what do you get over here? X. I'd write this as a half power. This would be x squared plus 5 to the 1/2. No, I do not recognize this. We recommend writing work down. Let me get the answer key on the side. I'm going to look at it. I'm not saying that would be cheating, by the way. I'm just simply saying I need to review this. And I'm going to say u equals x squared plus 5, and du would equal 2x dx. Am I seeing that? I sure am. All right, let's write this down then. So what's this guy over here? And again, you're going to get really good at this, but again, writing things down is going to be really important. So x dx is actually 1/2 of a du. And when you get 1 over u to the 1/2 power. Much easier problem. It's 1/2 integration u to the minus 1/2 du. This is 1/2. Well, like I add 1 to it, right? So it's u to the 1/2. That's not bad. Divide by half or multiply by 2 plus c. Wow, things are really working out nicely here. What do you get over here? The root of u plus c. What's u? X squared plus 5. Okay, let's look at the K, see how we did. Wow, another miracle. We did that. All right, let's look at number 12. And I'll do a copy paste that again. And we'll paste it over here. And let's go to town. All right, U substitution. Now, some people say, I can do this without U substitution. We're not denying it. What we're saying is we need to see you write down the U substitution. I'm going to say U is equal to 8 minus 8 theta. What's du? It's minus 8 d theta. All right, let's write it over here. A little star. And I'm going to say d theta is minus 1/8 of a du. And then I get sine of u. Well, this is easy. And again, it's easy if you know the antiderivative. If you don't, it's not easy. That's going to be minus cosine, right? Of u plus c. And what do you get over here? Well, you get 8, and you get cosine u here, plus c. What's u? Cosine 8 minus 8 theta over 8 plus c. Let's check it, see how we did. We did it wrong. We want to know we did it wrong. And that's why we like giving you guys answer keys. Gives you an advantage. I always say it's a rich kid's advantage. A lot of kids in school, particularly when I went to school, the rich kids had, private tutors where the tutors would actually be able to say, oh yeah, that's the right answer. That's the right answer. All right. All right, let's take a look at this one over here. So again, no hint again, given, no hint. What are you given over here? 14 theta sine 14 theta squared d theta. All right, let's go back over here. All right, let's see if we can do it. U is 14 theta squared. Du is going to be 28 theta d theta. Wow. Well, I'm going to say 1/2 of a du is 14 theta d theta. So why'd you do that? Not that you have to, but I'm seeing it. All right. And why do I see things? They're written to be seen. Put this down. So 14 theta d theta is 1/2 of a du. And then you get sine of u. And I think I can do that. And that would be minus cosine u plus c. It's going to be minus cosine for 2 plus c. What's u? Again, if you don't remember, look back. It's 14 theta squared. Again, there's other ways to check these guys, but we're doing homework is what we're doing. And let's take a look. Did I get it? It's a miracle. It really is. All right, let me copy. By the way, I do understand a lot of times what happens to students is they get confused. Now, certainly when someone gets confused, I would say skip the problem. All right, like if you're on the exam. If you're in home, you get confused, go back and review the notes. This is 14, paste this over here. And I'm going to blow this up a little tiny bit. All right, make a substitution. So I'm going to say u, whoops, let's go with that black ink. U is equal to 4x plus 6. Du would be 4dx. All right, I think I'm ready. Star secant squared u, and then dx is going to be 1/4 of a du. Now, I'm hoping you recognize this. If you don't, walk away. Say, I don't recognize that guy. You should, though. All right. I'm not saying forever, but in this local neighborhood, you should remember this guy. And it's the tangent. Tangent of u plus c. We'll check the key later. 1/4 tangent. What's u? It's 4x plus 6. Let's look at the k. And I'm hoping to see it. Yep, I'm seeing it. All right, let's go to the next one. This looks pretty easy. It does. So I'm getting a knack of this now. And so what I'm going to do when I get a knack of it, I'm kind of, I say everyone gets tired. And you say, I'm getting a knack of this over here. Let's just look at what's written over here. Looks like a good substitution. Like if this student said, good job, you did a good substitution over there. Did they do this okay? Let's see, 2x plus 10. They just factored it. Looks good to me. Next thing they do is they took the integral and they use a little star notation. They said e to the u. I see that. And then, that they have the du, I see that too. Good job. Can they integrate that guy? Good job. All right. Did they plug it back in for u? What to say u is x squared plus 10. Good job. All right. So that's not bad. Let's go to number 16. And again, I'm looking at it and I don't know, it's a little more difficult, doesn't it? Let's see if we can just do that one. So what I'm going to do, I'm going to say u is equal to e to the x plus 5 and du is equal to e to the x dx. I think I can write that down now. And that would be, see, 1 du and then u cubed. And this would be u to the minus 3 du Add 1 to the exponent. That's u to the minus 2. Excuse me 1 second. I'm going to turn my phone off. You should turn your phone off when you're doing homework too. Divide by minus 2 plus c. And what's this going to give me? Well, it's going to give me minus 1 over 2u squared plus c. Again, short memory, it's e to the x plus 5. Let's go next page. And I'm seeing it. I'm seeing the same answer, right? That's good news. All right, 17. I think it looks easy, but maybe not. Let's write this down. Let's blow this up. I don't want to see the k. U natural log of 4x du 1 over 4x times 4 dx. So du is actually 1 over x dx. Yes, these problems are written to work. So we give your 1 over u, and dx over x is just simply du. Do I know that guy's antiderivative? I sure do. It's a natural log, absolute value of u plus c. What's u? It's a natural log of 4x. Yep, they're written to work. Now, when I say that, it doesn't mean you can't make a mistake. Let's take a look. Bingo, got it. All right, let's look at number, oh boy, this doesn't look that bad. I like this better, I'll tell you why. This now is a definite integral. The other ones were indefinite. I like these things because they got a single number at the end, all right? Oh, by the way, I want to point out throughout the notes, you're going to see these things sprinkled. And what I mean by that, I often thank people for finding errors. What does it really say to me? Some students actually do the work, and you got to be really worried about that. What I mean by that is people that do the work tend to have a great deal of advantage on you, all right? It's like just showing up has a good deal of advantage with people not showing up. And you're ahead of the game, right? So if you're looking at things and you're finding errors, you're looking at it, all right? Let me do this problem over here. I think it's going to be easier for me, and I'm gonna do my little work over here. And I'm going to say u is equal to x plus 2, and du is equal to dx. All right, I got it. This looks like it's going to be really easy to do. I want to claim what we're doing now. I'm looking at something. I'm looking at this 3 over here, and this 3 corresponds to the x in the problem. But I want to go to the land of u's. So if x is 3, what would you get? You get 5. All right, let's keep going. This is 4. It corresponds to the limit on the x. I want to go to u's. So what's 4 plus 2? 6. Let's keep going. I'm looking at things. Do I know what x plus 2 to the 5th power is? Well, it's going to be u to the 5th power. All right. I'm going to check off everything that I've done so far. This, and I've done this. What's dx? It's du. I've done this now. Something's left there, though. I hope you see it. It's an x, right? What is x in the land of u's? It's u minus 2. Okay. Now I'm in the land of u's, and I'm going to stay there. So what do you get over here? 5 to 6, u6 minus 2u5 du u7 over 7 minus u6 over 6. 2 over 6 would be a 3 in the bottom. Limits of integration, 5 to 6. Boy, this looks nightmarish, numerically anyway. So I'm going to do it. It's going to be 6 to the 7th over 7 minus 6 to the 6th over 3 minus 5 to the 7th over 7 minus 5 to the 6th over 3. Now, if this is an exam question, I'll accept this as an answer. You actually did it. I got to be honest with you. The world's not so kind. So what I'm going to do is I'm going to definitely say there's a common denominator, right? What's the denominator going to be? 21. All right. It's going to be 3 times 6 to the 7th minus 7 times 6 to the 6th. 3 times 5 to the 7th minus 7 times 5 to the 6th. I'm still not satisfied. By the way, on exam, this would be wasting time though, and I'm going to discourage it. But I'm going to say 6 to the 6th. That comes out. And what do you have over there? 3 times 6, which would be 18, minus 7 over 21. We'll get to that later. Minus, what happens over here? Well, 5 to the 6 comes out, and we left off with, let's see, 3 times 5 is 15, right? Minus 7 over 21. And keep moving forward. 6 to the 6th. 18 minus 7 is 11 over 21 minus 5 to the 6th. And what do you get there? 15 minus 7 is 8 over 21. And I think I'm ready to write down my final answer. 21, 6 to the 6th, 11 times that, minus 8 times 5 to the 6th. All right, let's go to the next page. I'm going to look at it. And I point out that they did the arithmetic. They did it. All right. So this is where I want to copy their answer. I wonder, did I get it right? Oops, I didn't do a very good copy job, did I? And I'm going to get a calculator. And I'm going to switch screens for you. And I'm going to do my computation. And boy, am I hoping I'm getting it right, because I don't want to have to go back and do this again. Let me get my pen out. So I'm going to do another share with you. And I'm going to get my calculator out. And I want to do a new share with you. Give me a second to do so. My calculator was not open. And I got to do a new share with you guys, right? And I'm going to type in arithmetic over here. So let's type it in. 11 times 6 to the 6th power. This is painful, I realize that. Minus 8 star 5 to the 6th power divided by 21. What do you get? You get 388,216 over 21. Is that the same thing I had in my key? It certainly is. They did the arithmetic. How they do their tech? Probably used a calculator. All right, let me go back to my notes, by the way. And when I mean the notes, really the whiteboard. And just give me a second to do so. I feel pretty good about that. All right, let's do number 19. Number 19, I like. It's another definite integral. Makes it easy for me to do it. And I'll write it down for you. So it looks pretty easy. I'll say u equals, I'm getting a little better at this, x plus 6, and du equals dx. Let's write this down over here. Well, if x is minus 5, u would be 1. If x is 19, u would be 25. What's the root of x plus 6? It's the root of u, or u to the 1/2 power. What's dx? It's du. I still have the x there. What's x? It's u minus 6. Boy, this is deja vu. Let's keep moving. As I do this, mistakes can happen. And when they do happen, make sure you look at it. What do you get? U to the 3/2 minus 6u to the 1/2 du. Oh, I got to do this now. I'm in the land of u's. So I'm going to add 1 to that's 5/2, right? I'm going to divide by 5/2. Same thing as multiply by 2/5. Minus, I'm going to increase that by 1. That's 3/2. I'm going to multiply by 2/3. That would give me 4. And a limit integration are going to be 1 to 25. And again, I got to do the arithmetic, and it really hurts some people to do that, but it's 2/5. Now it's 25 to the 5/2. That goes 2.5 times in. So it's going to be 25 squared. That's 2, by the way. And then a root of 25. We'll do that later. All right. Minus 4. 3/2 is going to be 25 root 25. We'll do that later. That's the upper limit. The lower limit's really easy to do because it's a 1. What do you get over there? 2/5 minus 4. And again, I don't enjoy doing arithmetic, and I don't think most people do, by the way. But this is going to be 2 times 25 squared. I'll do that later. And this is going to be minus 20 times 25. Let me see if I did that right. 520, yeah. All right, let's go to the next thing. I know it's painful. That's going to be a 5. I'll look at the key later. That's going to be 2 minus 20. Did I do that right? Yeah, I think so. All right, this one, I don't want to do 25 squared, so I'll factor it out, 25. So that would be 2 times 25 is 50 now, minus 20. And this is going to be minus, let's see, minus a minus 18, right? So plus 18/5. Yep, it's painful. 50 minus 20 is 30. 18/5. 5 is a common denominator. That's going to be 125 times 30 plus 18. I was never good at arithmetic. 3 times 120 is 375. So 3750 plus 18 over 5. And it's going to be 3768 over 5. Who knows? Maybe I made a mistake. Oh, it's on the next page. I think I made a mistake. Let's take a look. Yeah, I think I made a mistake somewhere. Question is, where did I make the mistake? Oh, I'm sorry. I'm looking at the wrong answer. Of course I'd make a wrong mistake. It's right over here. I'm sorry about that. I was looking at 20 and said I made a mistake somewhere. All right, let's do number 20. And we did 19 fine. Let's put 20 down. What's it going to be? X squared plus 1. Boy, this is deja vu all over again. U, x squared plus 1, du, 2x dx. Yeah, you notice I'm writing quickly. This is true when you're doing homework. You're writing quickly. I mean, you're going through this. You want to go through it rapidly. You know, you're just kind of sitting around saying, I wonder what this is going to give you. Let's write this down now in the lands of u's. Well, if x is 0, u would be 1. If x is 1, u would be 2. What's x dx? That would be half of a du. What do you get on bottom? You would get u cubed. Boy, this looks like it's going to be pretty easy. What's going to be 1/2, 1 to 2, u minus 3 du. It's going to be 1/2. Increase the exponent by 1, which is minus 2 over minus 2. Limit integration 1 to 2. It's going to be minus 1/4. Upper limit, which would be 2 to the minus 2, which is 1/4, minus 1. What does this give me? Minus 1/4. And that would be minus 3/4, which would be 3/16. All right, I know I did it quick. There's no doubt about it. I'm saying 3/16. Let's take a look at it. 3/16. I feel good about that. Someone says, why aren't you looking at your work? I'm doing homework. That's what we want you to do too. We want you to do homework. All right, let's look at 21. And I think I'm getting a little better at this. I'm going to say, you know, you get tired too. And I got the u substitution down over here for you written down. This would be the du. It'd be 6 theta to the 50 theta. Looks pretty good. Make my substitutions. I want to point out, you know, if theta is 0 in the lands of u, it would still be 0. And if theta is 1 in the lands of u, it would still be 1. And then I'd get, theta 5, it would be 1/6 of a du. I definitely see that. And then I would get tan of u. All right. Now, I'd be honest with you. A lot of students look at the tan of u and they say, I don't think I could do it. I can't do that, they say. Of course you can. And we've done it before. Let me write this down over here. And tan of u du. And I think we've done this one before. And you may not remember it. All right. Now, certainly you can't remember things. It's like you can't remember family, maybe because you're not around them enough. You got to be around these guys to remember them. This is the sine of u over the cosine of u du. A substitution, for example, you might say, I can't use u now. I'll use v is equal to cosine of u. What's dv? It would be minus sine u du. I see that. This is going to be minus, that's a du, by the way, 1 over u. I'm sorry, 1 over v. And then, it would be dv now. And what's that going to be? That would be minus the natural log absolute value of v, and the v is cosine of u, plus c. Again, back in math 119, you did rules of logs, so it'd really be the reciprocal cosine, which is secant. And that's typically the way it's written down. All right, so that's where that guy's coming from. Again, I notice they're using the cosine over there, so I'll use this one over. They did use this one over here. So I certainly the one we've given you this one over here, though. But they wrote it down, and then they evaluated it. And again, I can't do the cosine of 1, but I do know it's a positive number. That's why the absolute value is removed. And the cosine of 0 would be 1, and the natural log of 1 is 0. So this looks good. Everything looks fine. All right, feeling pretty good about it. So let's do number 22. And again, you're a little tired looking at it. I'll just go through the work. Sine x looks pretty reasonable. Du would be cosine x dx. Make a substitution. Let's go through that. Now, if x is 0, what would u be? The sine of 0 is 0. And if x is pi over 2, what's sine of pi over 2? It's 1. That makes sense. Then you get u to the 8th. Let's see. Du looks pretty good. Antiderivative, fairly simple. U to the 9th over 9. Integration 1 to 0. Really simple evaluation as well. All right, let's see if there's another problem. No, we're at the end. We're at the end. All right, so what do we do? Start off slow. We gave you the u's. You did the work. Then they stopped giving you the u's. They went from an indefinite integral to a definite integral. They're slightly similar, but I do find definite integrals easier to do because I can go completely to the land of u's. We're not trying to trick you. We're trying to give you problems that work nicely. Are some of the problems difficult? Not really, but the arithmetic might have killed you. All right, that's what typically kills people. All right, thank you for listening, and we'll move forward. Thank you.